Here we go. Unit 5 is geometry and trig number 1. For the diagram shown, which statement helps prove that triangle ABD, so that's this triangle right here, is congruent to triangle CDB. So here we go. You got 4 options, A, B, C, D. Now, these markings mean that AD is parallel to BC, and at the same time AB is parallel to DC. So what you need, let's go through these diagonals of a parallelogram bisect each other. These diagonals do bisect each other because this, if D to E is the same as B to E, then that's kind of the middle right there, and A to E is congruent to E to C, that's the middle. So these diagonals do bisect each other. All sides of a rhombus are congruent. So here is your rhombus, and it doesn't say anything about AD being the same as BC, so we can kill this one. Corresponding parts of congruent triangles are congruent. D, alternate interior angles formed by parallel lines that are transversal are congruent. Okay, it's going to be D. They want you to go for D. And we did not do a lot of proving triangles congruent, but here are your 3 ways you can, I think maybe you did a little bit math one. Side, angle, side. Side, side, side. And angle, side, angle. So if you have one of these 3 things happening, so look right here. So these lines are parallel. So think of this top and bottom, and let's just look at this guy right here. Let's look at this as a transversal. So this guy means that angle and that angle, they're alternate interior, those are congruent. So angle B is going to match up with angle D. So far we're in good shape. B is in the same spot D is in. They're both in the middle, so that works out good. And then these angles over here are also alternate interior. So this angle right here and this angle right here. So here's what we've got. I'm going to break these apart. So we got 2 triangles. We have got A, B, D, and let's see, B has 1 mark and D has 2 marks, and now this guy right here, we've got, we'll call that B, C, D. This has 2 marks and this has 1 mark. And we know this. BD is congruent to BD. So here's what we've got. We have got an angle and then a side and then an angle. So these 2 triangles are congruent. If I can... I don't want to do that. Skew this over. Don't want to do that. Dang it. I want to grab this triangle. Just this guy right here. So if I grab it on B, pretend I grab it on B and then I rotate. So if I orient it to be in the same position as this one, so this one with the 2 markings, I'm going to grab this dot and I'm going to spin it around right here, and I'm going to have it, I'm going to draw it kind of smaller. I need to have it the same as this. I need to have 2 markings, 1 marking, and then this would be my point. So my 1 marker is D and my 2 markers is B and then C. So here we go. From A to B to D, so from A to B to D is the same as, so from A to B to D. I go from the one with no markings to the one with one marker, then down to 2. C, that's the one with no markings, over to the one with one marking, down to the one with 2. So they are congruent because they have an angle that's congruent, sides that are congruent, and another angle that's congruent. Number 2. Okay, this one maybe is just best with guess and check. So you have a segment AB, and C looks like it's not quite in the middle. And it tells you right here the ratio of AC, so AC to BC is 5 to 7. So if it would have been exactly in the middle, it would have been more like 6 to 6, because these two segments would be equal to each other. But it looks like AC is just a little bit smaller than BC. So ratio is 5 is to 7, or 5 is to 7. You can write it as a fraction if you want. So here is the plan. We know that this dot A is at 4, and then it's down 5, and this dot B is clear over here at 16 and down 2. So I'm gonna just look horizontally. What's the difference between 4 and 16? So if A is horizontally clear over here at 4 and 16, I know the total length is 12. So if you kind of look at these, if I were to choose A, the x is 5, so that horizontal would be pretty close to the 4. I'm probably liking maybe B or C, because I'm trying to find something that's maybe halfway between 4 and 16, and 9 looks like it might be, so let's try 9. Alright, so I'm going to try B. So if we try 9, I'm going to find the length of AC, and then I'm going to find the length of CB and see if that ratio really is 5 to 7. So the length of AC, to find length, use distance formula, or you make yourself a little 90-degree triangle. Gotta blow it up. That's A, that's C, that's always the hypotenuse. This is what I don't know. But I know if this is 4, and I go over to 9, I know that distance horizontally is 5. And let's find the vertical distance. Okay, it's a minus 5. So A is a minus 5, and I'm going to go to a minus 3.75. And the distance between that, minus 3.75 and a minus 5, is 1.25. Okay, so now I'm going to find this length right here. So I'm going to go A squared plus B squared equals C squared, and square root that, so it's going to be, probably change that to a decimal. It is going to be, so this distance right here, so if I go A, C, that's 5.15. Now I'm going to find the distance from C to D, and we're looking pretty good so far. So now C to B, I'm going to find C to B. Okay, C to B. So I'm going to make that the hypotenuse, make a 90-degree triangle. Here we go. Okay, C is at 9, and B is clear over here at 16. So the distance between 9 and 16, that guy is 7. And let's find the vertical distance. C was down here at minus 3.75, and B was a minus 2. Okay, the distance between a minus 2 and a minus 3.75 is 1.75. So now I'm going to go 7 squared plus 1.75 squared equals c squared. Square root of that, and that will give me the distance. And that distance is 7.11. So there we go. B was a pretty good guess. The ratio is pretty dang close to 5 to 7. Okay, number 3. What is the least amount of info that you need to show that two triangles are similar? Okay, similar means the same shape but different size. So it is the exact same shape, but it is the different size. So triangles, let's say you've got a equilateral. So let's say you got a 6, 6, 6, and if I double it, it's the exact same shape, but the size has been doubled. So a 6, 6, 6 is congruent to a 6, 6, 6. Congruent means it's the same shape and size, but it is only similar to the 12, 12, 12. So similar means it's been shrunken or dilated, it's been blown up. So the minimum we need is one side and one angle, two angles, and the included side, all three angles. This can be B. All you need to know is two angles. Because if you're given that's a 60 degree and that's a 60 degree, and then you're given some other triangle that has that's a 60 and that's a 60, you know they've got all three had to be 180, so this missing one has to be 60 and this missing one has to be 60. So they don't need to give you all three angles. All they needed to do is give you two, and then you can find the third. So for similar triangles, every single angle needs to be the same. So you could have a 90, 30, 60, and then in your other one you have 90, 30, 60. So they would be similar. Okay, number 4. Xavier cannot walk from point A to point B because there's a pond in the way. So here's A, here's B, here's some pond. From A to B, that's the direct path. So he can't go straight there because there's a pond. So he starts walking at an angle of 30 degrees from the direct path. So 30 degrees. The pond's kind of in the way. So let me shrink the pond. Here's A. So he's going to take off at 30 degrees. Okay. Then he's going to make a 90-degree turn and head to B. So there's my 90. And that is 30. So the triangle I'm looking at, I kind of got it too cluttered. So that's 30. That's 90. He walks 40 feet after the 90. So there's 40 feet. So that's B. That's A. And this is a special triangle, 30, 60, 90. So the question is, if he were able to go across the pond in that straight path, how far would he walk? They want this, from A to B. So since it's 30, 60, 90, it's half of an equilateral, and I know that's 40, 80, 80, and that would be 40 square roots of 3. So from A to B is 80. Okay, this question, you probably won't see it. This is proportions. So if you got a 12-foot flagpole and it casts a shadow that's 3.5, so this is what we're looking at right here. So the sun is going to shine the same on all of these objects. So 12 feet is to 3.5 feet as 30 feet, so you put the height of the building, is to its shadow, we don't know a shadow, which will be the same as 18, the height of the tree, to its shadow, we don't know. So I'm going to take these two, and a proportion, you just cross multiply, so I do 3.5 times 30. So 30 times 3.5 cross that way, and that is 105 equals cross this way, 12x divided by 12 divided by 12, 105 divided by 12, x equals 8.75. But if you got to change it to a decimal, you got to know how to do that on a calculator. I'll show you. That is the same thing as 35 fourths. And that's an improper fraction. 35 fourths is the same thing as, how many times 4 going to 35? 8. And 3/4. So what one did we do? We just did that. So 8 and 3/4 feet. And the tree, it's going to be the same thing. 12 is to 3.5 as 18 is to x. Cross multiply 18 times 3.5. 63 equals 12x divided by 12 divided by 12. 63 divided by 12. You got 5.25, so that one's not bad. That one's 5 1/4. No, this one was not bad either. That was kind of goofy. 8.75, that's 8 3/4. That's easy. Okay, number 6. Here we go. Trig. So the sine from phi, that's this marker right here, is 3/5. And sine, you gotta remember your SOHCAHTOA. Sine is gonna be opposite over hypotenuse. So phi, this angle right here, there's really not a triangle, so you gotta make one right there. So the opposite is gonna be this piece, and opposite is 3. There is my 90. Hypotenuse is going to be opposite to 90. So that's my hypotenuse. And this is a Pythagorean triple. So we're going to find this piece right here. And you could do Pythagorean Theorem, a squared plus b squared is c squared. Or this is the most famous Pythagorean triple. So this side's got to be 4. And that means this is 3. And this is 4. So what's the cosine if you're going from theta? So now right here is theta. Cosine is adjacent over hypotenuse. And adjacent is going to be 3/5. So it's going to be B. 7. Tangent of theta is going to be negative. And the sine from theta is square root of 2/2. Okay, sine is opposite over hypotenuse. So check this out. Here are your options. Let's draw a triangle. There we go. Okay, if theta was here, opposite would be square root of 2 over hypotenuse would be 2. Okay, now if you flip that this way, it would look like this. This piece would still be 2, square root of 2, and this piece would still be 2. Now if you flip it over the x-axis, and we put theta right here, this piece, all I'm doing is drawing this triangle in each of the 4 quadrants, and you just flip it over the y, flip it over the x, flip it over the y. So it's going to look like kind of a bow tie. This piece would be square root of 2 negative. And this piece would be 2. And this piece right here, I guess we could find this piece. This piece is going to be, let's say we want to find it using Pythagorean Theorem. So we could go x squared plus square root of 2 squared equals 2 squared. So x squared plus, that's going to kill the square root. 2 equals 4. So x squared equals 2. And square root. So this is going to be square root of 2. But now over here it's going to be a negative square root of 2. So I think we can stop. Because the tangent is negative. Tangent is TOA, so it's opposite over adjacent. And this one's going to be your winner. Because if you do opposite, that's square root of 2. over adjacent, a negative square root of 2, it's going to be a negative 1. So tangent will be negative when it's flipped over into quadrant 2. Okay, identify the triangle that's similar. So similar means the same shape. And your printout is different than this. It's jacked up, so you can't refer to your printout. So here's the given triangle. Now what you gotta do is this one is the big one, and this one is the small, and this one is the medium. You need to know which one it is. So we're gonna compare this to, let's see, pick one. So if we pick A, this one is the big, and this one is the medium, and this one is the small. Okay, we're going to kill A because look, compare the big to the big. 12 is to 12, medium to medium, 9 is to 9, and then compare the small to the small. 6 is to 4. These are congruent, these are congruent, these are different. So they are not the same shape. I think it's going to be D. Let's look at D. Okay, this is the big, this is the medium, and this is the small. So let's compare big to big. So 12 is to 8. Now medium, I'm going to always put these pieces on top. 9 is to medium. 6 as, let's do small to small. 6 is to 4. Okay. Now these fractions, if you simplify them, they will be 12 is to 8. That's the same thing as 3 is to let's see, what did I divide by? Divide them both by 4. Divide that by 4. So 3 is to 2. And then 9 is to 6. Divide those both by 3. So that will be 3 is to 2. And divide 6 and 4 by 2. So that will be 3 is to 2. So that's your ratio. The scale factor is 3/2. So this guy is 3/2 bigger than this guy. So it is D. Two triangles have two pairs of congruent angles. What's got to be true? So if you have two triangles and that angle matches that angle and that angle matches that angle, by definition this angle has to match this angle. So you've got all angles are congruent. That means they are similar, but they don't necessarily have to be the same size. So if a ridge of motion that transforms one to the other, this one could be 10 times bigger than this one. So that one's implying that they're the same size also. And they share at least one side length. That's not really necessary. So if you have info about all the angles matching up, all you know is they are similar. They are the exact same shape. 10. Sine is 4/5 in quadrant 2. So here we go. Here's theta. Your triangle is going to look like this. So sine is 4/5 opposite over hypotenuse. That means this is 3. Find the cosine of it, but this 3 is actually a -3 because on the x-axis you're going left of 0. So cosine is going to be A, adjacent over hypotenuse, a -3 over 5. 11. Okay, this one's kind of tough. A circle circumscribes a triangle on the coordinate plane. The vertices of the triangle, let's do the triangle 0 and 3, 4, 0, and 0, 0. Okay, here's your triangle. Chink, tink, tink. So a circle circumscribes, that means this. It is going to hit all 3 of the vertices. That is circumscribe. If it was inscribe the circle would be like this. Okay, we need to find the center and the radius. So here's what we're going to do. We are going to draw a rectangle. And let's find the length of it. The length, 0 to 0 to 4, 0. So this rectangle, that piece is 4. And how tall is it? It is 3 tall. Okay. Now, it's going to be 90. That's a 90. And this is the most famous Pythagorean triple, so this hypotenuse is 5. And if we hit a diagonal going this way, that's 4, and that's also going to be 5. So that center of my rectangle is also going to be the center of the circle. So to get to this spot right here, okay, it is going to be halfway between here, so it's going to be over 2. It's going to be halfway between here, up 1.5. So I can kill A and B. It's either C or D. And the radius, if I go from the center of here to the circle, since that diagonal is 5, this is going to be 2.5. And that's the same as 5/2, so we're going with D. Which property is sufficient to prove that a parallelogram is rectangle? We've never talked about this. Okay, for a parallelogram, the definition of a parallelogram is the opposite sides are parallel to each other. So your opposite sides are going to be congruent, and you can stretch the parallelogram out quite a bit, but look at the diagonal. So this diagonal is about 3 tall, and this diagonal is, if I stretch it out, the more I stretch it out, the longer this diagonal gets. But when you make a rectangle is a parallelogram with 90-degree angles. So if I park this right on 90 degrees, which might be hard to do, there we go, 90. Okay, at 90, we just found that out when we did our circle. Your diagonals are going to be the exact same size because everything is centered. So this diagonal is 5.83, this diagonal is 5.83. Right at the center, your diagonals will be congruent when it is parked at 90. When you start stretching it away from 90, they're going to change. This one right now is 7 and change, and this one is 4 and change, so this one's longer. But when you park it right at 90, your diagonals are congruent. So, diagonals are congruent. That's going to be C. Given segment AB, so A, B, and C is the midpoint, so C is right here. There's a line through C that's perpendicular, so there's a line that makes a 90 right there through point D, so we'll call this point D. Which theorem proves that AD, so if I connect AD is going to be congruent to BD. So here, this is not a theorem. It's going to be one of the three: angle, side, 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 or side, angle, side. So you can kill that one. So here's what you got. Okay, this is an isosceles triangle. So if this distance right here is congruent to this distance, that means D is exactly centered between A and B. That means that C is a midpoint. And you know, so look at these triangles right here. If I split this one on the left, that is let's see, there we go. That piece, AD, is congruent to DB, and AC is congruent to BC, and this piece is congruent to this piece because it's the same piece. So you have side, 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 side. 14, the cosine of theta is 2/3. Okay, the cosine is ka in quadrant 4. So here's your triangle in quadrant 4. There's theta. So the adjacent is 2. Hypotenuse is 3. We've got to find the opposite. And it doesn't look like it's a Pythagorean triple, so we're going to have to use Pythagorean Theorem. 2 squared plus x squared equals 3 squared. 4 plus x squared is 9. X squared is 5. Square root. This piece is the square root of 5, but it's negative because it's on the y-axis. It's going towards negative infinity. So tangent is TOA, opposite over adjacent. That's my opposite. Negative square root of 5 over adjacent. 2. You're going C. And 15. Okay, create two true statements. So cosine from A. If you do cosine from A, so let's label these guys just like 1, 2, 3. Cosine from A would be 1 over 3. So cosine of A is 1 over 3. Cosine of B, cosine from B would be adjacent. That would be 2 over 3. Cosine from C, okay, that's from the 90. We're not going to do that because if you're going from the 90, don't ever go from the 90 because opposite the 90 is the hypotenuse, and it's kind of confusing. Well, which one is the opposite, which one's the hypotenuse? So don't worry about cosine from the C. Okay, sine from the A. Sine from A is opposite over hypotenuse, so that would be 2/3. Sine from B would be opposite over hypotenuse. That's 1/3. And sine from C, don't do that. They're going from the 90. So here we go. Cosine from A is going to give you the exact same thing as sine from B. And cosine from B will give you the exact same thing as sine from A. The very last one. Hawthorne and elm are parallel to each other, so we got some transversals. How far in feet is the intersection of elm and oak from the intersection of, so elm and oak, that's their intersection, from the intersection of oak and cherry? Oak and cherry is right there. Okay. Alright, so this is going to use proportions. We're going to use similar triangles. We haven't done any of similar triangles. So because these are parallel, this transversal, that angle, is going to be the exact same as that angle, because they're alternate interior. And if you look at this as a transversal, this angle is going to be the exact same as that angle. Whoops, I should only do 2. Okay, now this angle is the exact same as that because they're vertical angles. So I know in the little triangle and the big triangle, they're the exact same shape. This one's just been blown up a little bit. So here we go. Let's compare this piece to this piece. So 352 is, now this is the small, the big one's going to be 484. And I want to find on the big one, I want to find X. I want to find oak. Okay, now check it out. X is between the one with 1 mark and 3 marks. So the one with 1 mark and 3 marks is going to be on top. You got to put 312. So now you cross multiply. 484 times 312. Whoa. 484 times 312 is 151,008. And then cross multiply this way. 352x. Then divide by 352. And x equals 429. So x is C.